Hello everyone. In this video of 8086 microprocessor, I am explaining subtract instruction. So what is this subtract instruction? Let's see. Subtract instructions are the arithmetic instruction. That means it belongs to arithmetic group of instruction of 8086 microprocessor. It is used to subtract byte to byte or word to word. We know that the length of byte is 8 bit and word consists of 16 bit. In 8086, the size of word is 16 bit. These are the prerequisites. If you want to understand this video, you should know the block diagram of 8086 and memory segmentation and how to calculate 20-bit physical address of memory location. This is the format of subtract instruction that says subtract. On left hand side there is destination and on the right hand side there is source. Now what this says, it says subtract the data in the source from destination. So remember that it is always destination minus source. It is not source minus destination. Remember, it is destination minus source. There are various possible combinations available in subtract instruction. That means if destination is register, source may be register. Destination register, source may be immediate data, 8-bit or 16-bit. Destination register, source may be in the memory. If destination is in memory, source may be immediate data. If destination is memory, source may be register. Remember that destination and source both cannot be memory. Both can be register. One can be register, other can be memory, but both cannot be memory. So we are going to study in this video about subtract instruction for byte operation, subtracting instruction for word operation, and subtract instruction for byte operation. This is SBB subtract with borrow, and this is also subtract with borrow for byte and word operation. Now let's take the first example that says subtract RD, RS. RD stands for destination register and RS stands for source register. This instruction belongs to register addressing mode in which source and destination both are register. That means data is available in the registers. So operand, let's take an example which says subtract AL, CL. AL and CL are general purpose registers in 8086. We know that in 8086 there are various general purpose registers. We can use them as a 8-bit register or we can use them as a 16-bit register. If we want to use them to store 8-bit of data or for operation of 8-bit data, we have to access them as AL, AH, BL, BH, CL, CH, DL, DH. And if we want to use them to store 16-bit of data, we have to use them in pair like AX, BX, CX, and DX. Now, since here instruction itself indicates that there is AL and CL given, it indicates that instruction want to subtract 8-bit of data. So what this instruction says, subtract the contents of register CL from contents of register AL and store the result in AL register. Remember that result will also always enter in destination register. This is arithmetic and logical unit of 8086. Let's assume that this AL holds F0, the data is shown in the form of hexadecimal number, and CL holds 0E. So this is what AL holds, F0, and this is CL 0E. So it is always AL minus CL. So what happens? This F0 minus 0E, then 8086 converts it into binary number and actually the binary subtraction takes place. After binary subtraction, we get this result and which indicates E2 in hexadecimal. So this is E2 and where result goes, result will enter into AL register because AL is destination register. So this instruction was about 8-bit subtraction. Now let's see the instruction for 16-bit. If we want to subtract two 16-bit numbers, then in place of this 8-bit register, we have to use 16-bit register. Everything else remains same. What this instruction says, subtract contents of DX register. DX register means combination of DH and DL. That means data from combination of DH and DL from BX register. BX means combination of BH and BL, and store the result in BX because BX is destination register. So what happens? Let's assume that DX register holds 0B, 06 and BX register. This is BX register. This is DX register. BX register holds F0, F0. So what happens after execution of this instruction? It will take contents of BX register. It will take contents of DX register and subtract. And then we get E5, EA. Now where result will enter? Result will enter into BX register. Now remember that this is a 16-bit result. So this right hand side, this side is known as lower byte of result and this side is known as higher byte of result. So this lower byte goes into lower BL, lower part of B register, and higher byte of result enters into higher part of B register. So this is how EA will enter into BL and E5 will enter into BH register. Now let's go to the next. So next example is subtract AL and 8-bit data. Now here source is 8-bit data. That means 8-bit data is specified in the instruction and destination is register. This register may be any 8-bit register. What this instruction says, subtract 05, which is the 8-bit data specified in the instruction from the contents of AL register and store the result in AL register. The operand is AL is missing here. The operand is AL and 05. This is the operand part and this is mnemonic part of instruction. So let's assume that this AL register holds F0 and this is 05. So what this instruction does, it will take F0 from AL register and this 05, which is the data specified in the instruction, it will subtract it. This is a binary subtraction. You can see F0 minus 05 and result is EB in hexadecimal, and then this result will get back to AL register and it will overwrite the contents of AL register. Why result is entering into AL register? Because AL is destination register. Now let's see the flags. Now we know that these are the status flags of 8086 microprocessor. I explained this in detail in the processor status word video. One more time I am explaining in short. After arithmetic and logical operation, the status flags will appear. Now since no carry, no borrow is generating after this subtraction, the carry flag will be 0. Now what is parity flag? How many ones this result holds? This result holds 6 number of ones. When result of subtraction holds even number of ones, the parity flag will set to 1. Now combination of 4-bit is known as nibble. If carry or borrow propagates from one nibble to another nibble, that means from lower nibble to higher nibble, then auxiliary carry flag will set to 1. So in this subtraction, borrow is flowing from one nibble to another nibble, and that's why auxiliary carry flag is set to 1. Now result of subtraction is non-zero, and when result of subtraction is non-zero, zero flag is always 0. And most significant bit is 1, that indicates result is negative, and that's where sign flag is. Now let's understand the another type of subtract instruction. This is subtract destination register. Now 16-bit data is specified in the instruction. So previous one was 8-bit data. Now 16-bit data is available in the instruction. And since instruction wants to subtract 16-bit data, the destination register should be also of 16. So this is the example, subtract AX, 2000. So this AX is a 16-bit register and this 2000 is in hexadecimal and it is a 16-bit data specified in the instruction. What this instruction says? This instruction says that subtract this 2000 from contents of AX register and store the result back in AX register. What is AX register? AX register is combination of AH and AL. Let's assume that this AH register, AH and AL register holds 25, 25. So what happens? It will take 2525 from AX register minus this 2000 which is specified in the instruction, and result is 0525. And then the result will go back to register. But how it will go? You know that this is a lower byte and this is higher byte. So lower byte will go on the lower part of A register and this will enter into higher part of A register, and hence 25 will enter into AL and 05 will enter into AH register. Now let's see next. This instruction example is subtract destination register and contents of memory. Now in this instruction, source is memory and destination is 8-bit register. Now since destination is 8-bit register, it indicates the 8-bit subtraction and not the 16-bit subtraction. Now what this instruction says, subtract the contents of memory. Contents of memory. Now why I said memory? Because these brackets indicate that this is not data like the previous instruction, but it is an offset of memory location. So what this instruction indicates, subtract the contents of memory whose offset is 4321. Whose offset is 4321 from the contents of CL and store the result back into CL. That means, suppose this is data segment and these are various memory location. All locations will carry some data, and this instruction wants to subtract the number, the data from some memory location from CL. But which memory location whose offset is 4321? What is offset? What is offset? Offset is distance of this required location from base location. So if this is data segment, we have already seen that this is the bottom location and this is top location of data segment. This is any random memory location which is 4321 locations away from this base location, and hence it is said that 4321 is the offset of this memory location. Now here data is shown in the form of binary. It is just for convenience. In some instructions I have shown in binary and somewhere I have shown in hexadecimal number. It is just for understanding. Otherwise we always represent numbers in hex numbers, not in binary, because it is very difficult to write binary numbers. So how to calculate the address of this memory location? Because now it is subtraction of contents of CL. Where is CL? CL is general purpose register, and contents of memory whose offset is 4321. Then how to calculate the address of this memory location? Now we know that there is a fixed formula. We have studied earlier that there is a fixed formula for calculation of address of memory location. What is that formula? Contents of segment register into 10 plus offset. So let's assume that data segment register holds 5000. So how to calculate? It will take this 5000 into 10 plus this offset, which is already specified in the instruction, because it is direct memory addressing mode instruction in which offset is available in the instruction. So plus this offset, so we got 54321. What is this 54321? This is the address of this required memory location. Then what is the address of this bottom location? So in offset, if we add 0000, it gives us address of bottom memory location. So this is the address of required memory location, and then let's assume that CL holds this number. So what happens? It is CL minus contents of, again bracket indicates contents of this memory location. It is 54321. That means we are talking about same memory location. So CL contents minus contents of this memory. If we subtract this and this number, memory number from contents of CL register, we will get this result, and then result will enter into CL register. Why? Because CL is destination register. So it was about how to access the memory. Now let's see next type of instruction. What this instruction says, subtract contents of memory and contents of 8-bit register. It is same as previous instruction, but what is the difference? The difference is in this register is at the source location and memory is destination. That means here It will subtract the contents of register from the contents of memory and store result in memory. So this is example. In this, just position is exchanged. It is similar to previous, but only position of source and destination is exchanged. What this instruction says, subtract contents of CL register from the contents of memory. Which memory? Which memory whose offset is 4321, which is 4321 locations away from bottom location, and store the result back into memory. So again, let's assume that DS holds 5000, and then we calculate we calculate the address of this memory location by using the same formula, that is 5000 into 10 plus this offset. Why we have taken 4321? Because 4321 is specified in the bracket and it indicates that it is the offset of required memory location. So it will take this memory contents minus CL and will store back into the memory. Now let's assume that CL holds this number and memory holds this number. So what will happen? It will take contents of memory. See, this is memory 11110000 and then CL 110000 all zeros, and then after subtraction it will get this, and now the result will enter into memory location like this, and it will get overwrite the result. The contents of memory location will get overwrite. That means it will change, but contents of CL will not change. Why? Because it is a source register. Now remember that whether it is a SUB instruction or SBB instruction, in all instructions flags will affect the way I have explained earlier, but I have avoided to explain it in every subtract instructions. Now, next example is subtract. Now here it is written 16-bit register and memory. That means subtract the contents of memory from 16-bit register. So this is the example, and this is the operand part, which says subtract the contents of memory from contents of 16-bit register and store the result in CX register. Now here, since CX register is mentioned, it itself indicates that from memory also the instruction will access 16-bit number. But one offset indicates only one memory location. Remember that one memory location holds only 8 bit of data, and hence since this instruction wants to access 16 bit of data from the memory, it has to take 2 consecutive memory locations. That means since instruction wants to subtract 16-bit number from 16-bit register and one memory location holds only 8-bit of number, it has to take 2 consecutive memory location for accessing 16-bit number. And hence what this instruction says, subtract the data from memory location. Which memory location? Whose offset is 4321. Whose offset is 4321. That means this memory location, which is 4321 locations away from base location, and 4322. And 4322 means next memory location, whose offset is 4322 from CX. Subtract it from CX because CX is destination register, and store result in CX because CX is destination. Then how to calculate address of this memory location? The formula will be same. Again, we will assume that DS holds 5000, then it will take 5000 into 10 and plus this. So we will get address of this particular memory location. So it is 54321. Then what will be the address of next memory location? Next memory location will be plus 4322. Here it will become plus 4322, and hence next memory location address will be 54322. Now, what CX indicates? CX indicates combination of CH and CL together. Let's assume that CX register holds B325. So it will do the subtraction like this, CX minus contents of memory location. Now how to write this 16-bit? It is very, very important, and listen this very carefully. Now remember that this is 2 bytes. This is higher byte. and this is lower byte. So on lower byte side, you have to write contents of lower address, and on higher byte side, this side, you have to write contents of higher address. Higher byte, higher address. Higher byte from higher address. Lower byte from lower address. So number will be like this. CX holds B325. So it is B325 minus, it is AA30. Always remember it is AA30 and it is not 30AA, because 21 is lower address. So lower address byte will come over here like this, and higher order address, higher order byte from higher order address like this, and then contents of CX register, and then we got result 08F5. Then again the higher byte of address. This F5 is higher byte with lower byte. Sorry, F5 is lower byte of address. It will enter into lower side of C register, and 08 is higher side, will enter into higher side of C register. So result will enter F5 into CL and 08 into CH register. Now let's understand next instruction. Now again it is similar, but now here it will access 16-bit number. So what this instruction says, subtract the contents of CX register from contents of memory. Now it is opposite, and store the result in memory. It is similar to previous instruction. It is similar to this instruction only, but only position is exchange. Position of CX and memory is exchange. That means now CX is source register and memory is destination. So result should enter into destination. Everything else is same. The calculation of address will remain same. Again 54321, and this again CX, assume that CX holds 2025, and you have to consider the contents of these two consecutive memory locations. So 4321 is the offset. So it will take contents of memory, that is AA30. Again same, AA30 minus 2025 now, and result will enter into memory. Result is not entering into register because memory is on destination side. Now let's understand next instruction. Now here it is SBB instruction. SBB stands for subtract with borrow. Here again various possible combinations are there. That means both can be register, one register, another memory. You can write here this side register, this side memory, or here register and here 8-bit data, or here memory and here 8-bit data. All combinations are possible, but remember that both cannot be memory. That means source side and destination both cannot be memory. Both can be register. Okay. So what is this example? Example says SBB BH, 04 operand is, BH is also an operand. So I forgot to write here. So BH and 04 is operand side and SBB is mnemonic. What this instruction says, subtract 04. 04 is the 8-bit data specified in the instruction. So subtract this 04 from the contents of 8-bit register BH. BH is 8-bit register, and store the result with BH. But then what is the difference? It is subtract with borrow. That means subtract this 8-bit number specified in the instruction from BH register with borrow and store the result in BH. So here it is written subtract 8-bit number 04 specified in the instruction from BH register with borrow. Now what is difference? It is with borrow. The with borrow means with carry bit, and store result in BH register. So let's assume that carry flag holds 0. This is just an assumption, and BH register, which is a 8-bit register, general purpose register of 8086 microprocessor, holds F0. This is arithmetic and logical unit. So what happens? It will take F0 from BH, then 0 from 04, which is 8-bit data specified in the instruction, and then minus carry flag. Now here if it is 0, it will subtract 0, and if carry flag is 1, it will subtract 1. So how it takes place? It will take F0, this is F0, minus this 04. This is a binary subtraction. After that we got some result, and after that it will subtract carry flag. It is with carry. Result is EC and result will enter into BH register. Why in BH register? Because BH is destination. BH is on destination side and flags will affect based on this result. Now see in all instructions, these flags will affect based on this result. Again, no borrow generated, so carry is 0. Parity is 0 because number of ones are odd. Auxiliary carry, no carry is flowing from this side to this side. Then result is non-zero, so 0 flag is 0. Most significant bit is 1, so sign flag is 1. So these flags will change in every subtract instruction, whether it is SUB or SBB. Now let's go to the next. Again, it is subtract with borrow, but now here both are registered. That means source is also registered, destination is also registered. Here I have taken an example of SBB, BH, CH. So BH and CH both are 8-bit register and hence it indicates that it is a 8-bit subtraction. In place of this, if I write BX and CX, it indicates 16-bit subtraction. That means it indicates the word operation of 8086. What this instruction says, subtract the contents of CH register from contents of BH register with borrow and store result in BH register. Now these are the example. These are general purpose registers. So BH register, where is BH? BH holds F0 and CH, where is CH? CH holds 0. And carry is 1. This is assumption that carry is 1. So it will take F0 minus 03 minus 1. And after binary subtraction, F0 minus 03 and then minus this carry flag, we get EC. And then this result will enter into BH register. Now, is it necessary that every time it should be BH register? No, it can be any register out of these 8 registers. So, flags will affect according to the result of subtract. Now, let's understand next type. Now, here it is again subtract with borrow. This is 8-bit destination is 8-bit register and here it is memory. But the way of accessing the memory is different. The way of accessing the memory is different. So in some instruction, it will be directly offset specified. In some instruction, it may be given only in the pointer register. In some instruction, the combination of all these. So we have studied all these type in addressing modes. So let's see what this instruction says. This is subtract with borrow because it is SBB and these are operands. What this instruction says, subtract 8-bit data. 8-bit data, why 8-bit data? Because destination register is 8-bit register. From memory location. Which memory location? Some memory location of this data segment. But which memory location whose offset is addition of these 3? Whose offset is addition of all these 3? Means offset is specified in BX register, SI register and plus 4. 4 is, it is a displacement specified in the instruction. So this is suppose required memory location in which 4A is the data available and this instruction wants to subtract this 4A from CH. But how to calculate the address of this memory location? Let's assume that DS register holds 5000. This BX, this is just an assumption. BX register holds 4321. It may hold any number. SI holds 1001 and 04 is the displacement. So what happens? Addition of these 3 gives us effective address. What is effective address? Effective address is same as offset. That means distance of this location from bottom location. Now when we add 4321, 1001 and 04, we get 5326. That means this required location where from we want to access the data for this instruction, it is 5326 locations away from base location. How do we calculate this? 5326? By adding all these 3. That means contents of BX, contents of SI and 04 displacement. And let's assume that carry flag is 1. Now let's see what happens. How to calculate physical address? The physical address again formula is same, ds into 10. Now here it is not 4321, it is wrongly mentioned. Forget about it. And this is correct statement. This statement is correct. So how to calculate physical address? Take contents of ds multiplied by 10 plus 4321, that is 4321 which is in bx, then 1001 which is in si plus 04. So this together addition of this is 5326, that is the offset. So we got this address, that is 55326. So address of this location is 55326. So what this instruction says, subtract the contents of memory. Which memory? This memory location whose offset means whose distance from base is addition of these three from, subtract from ch. Where is ch? This ch. What it holds? Let's see. It holds 4b. With borrow means with carry bit. What carry holds? 1. So let's see what happens. It will take 4b ch minus 4a. 4a is contents of this memory location, and minus 1. What is this 1? 1 is nothing but this carry bit, and after subtraction we get 0 0. So where this result will enter? This result will enter into ch register, because ch is the destination register. So it was all about the subtract instruction, the subtract, simple subtract, and subtract with borrow. What is the difference? The difference is we have to subtract the carry bit. If carry bit is 0, we subtract 0, and if carry bit is 1, we subtract 1. For subtract, simple subtract and subtract with borrow, all combinations of source and destinations are possible. So you can take any combination. So I hope you understood the concept of subtract instruction. If you have any problem, you can always ask in the comment section. Thanks for watching. Thank you very much.